Yeah, I mean, I think that ultimately, I think that Stellar can be the glue that 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 allows all these different digital currencies to be able to interoperate. I mean, I sort of one of the things that we've often said is that uh, we want we want Stellar to be like email for money, basically.
Dude, this is exciting though. I like the fact that I'm going to get to talk to you about cryptocurrency because you're like Mr. Crypto.
Maybe probably a lot of people who are even more Mr. Crypto than I am, but um, I mean, I guess relatively speaking, I was a somewhat late comer to the whole blockchain scene, um, and but I got into it with Stellar because Stellar had kind of like a slightly different take that seemed more interesting to me. So,
What was more interesting about it?
well, the thing that never quite made sense to me is that I mean the way I look at it is blockchain gave us these two like really amazing things that before Bitcoin, like if you'd asked me about either one of them, I would have said this is impossible, right? So one of them is how do you commit transactions irreversibly and atomically across sort of mutually distrustful parties who've maybe don't even never even heard of each other before, right? So the idea that like we could both agree that I've sent you a Bitcoin and like we can never go back and change that. That was pretty surprising. And then the second thing that was pretty surprising is that we could create some new virtual currency and distribute it in such a way that there was a limited supply, but people actually believed it had a huge amount of value, right? I mean, the idea 12 years ago that Bitcoin would be worth $50,000 is like unbelievable, right? So that said, the virtual currency thing never interested me as much because it seems like we already have money, and we also have like economists who study it and who like manage central banks and try to set monetary policy in a way that's like good for the country and so on. And so, I was never on board with the idea of replacing money with an and replacing economists with like an algorithm that no one can change. But I did agree that sort of payments were broken, and that there's a lot of people in the world who are underbanked, and it's very expensive to provide financial services to people, and there's very little innovation. And so the idea of creating something that could have the benefits of blockchain in terms of being, self-serve for developers to come and implement things, but that also worked really well with just normal money or other sort of traditional assets, seemed really appealing to me. And so that's how, when Jed approached me in like 2014, I got very interested and said, yeah, maybe I could actually join you guys and work on this.
What were you doing at the time?
Well, I mean, what's still my day job, which is that I'm a professor of computer science at Stanford. But Jed, he approached me, I think it was June of 2014, and we had a mutual friend. I mean, I'd known him before. I'd invited him to give a keynote at a workshop on peer-to-peer systems many years before. But he approached me through a mutual friend, and then turned out his office was relatively near my house, and so we went and talked, and he explained the Stellar thing to me, and he said, well, one of the things we want to do is, we want to fix our consensus. We want to come up with a good consensus algorithm for this, and maybe you have some students who might want to work on this or something. And I said, well, this is kind of right up my alley, this distributed systems and consensus. Maybe I could be an advisor to here. And so he wrote me kind of an offer that was sort of multi-tiered, that could have like multiple levels of involvement. And what I found was that the entire next week, whatever I was supposed to be doing at Stanford, I was actually daydreaming about this problem. And I was like, wait a sec, this problem is like hard enough that nobody's solved it yet, but it's tractable enough that I think I can crack it. And here's this immediate application that could potentially, make the world a better place, and, help underbanked people and promote innovation, and, sort of bring transparent markets places where we don't have them. And so I was like, that's kind of really the sweet spot for research. So I said, well, Jed, why don't I come actually join you guys full time? And because it's summer, so I can easily sort of change my involvement at Stanford. And so then I just went for the next 3 months full time. And then I've been sort of on and off full time or part time since then.
So had you like done this advisory thing before, or was this the first time that you've ever done it?
Oh yeah, it's pretty common for faculty members at Stanford to advise companies, and it can go. You typically nominally when you're full time at Stanford, you have approximately 20% time to consult. So it's normal to spend a day a week someplace outside of Stanford, or up to 130 hours a quarter if you're doing it hourly, and so so that involvement can take any number of forms. It can be just a couple hours a month kind of thing, or it can be a 1 day a week thing, or you're allowed to take a leave and where Stanford doesn't pay you, and you just work someplace else. And at Stanford, because they want you to commit it to Stanford, I think you have up to you can take 2 years leave every 7 years, right? So they want you on campus at least every 5 out of 7 years, but there's no problem taking a quarter off. In summers, you can always take off because you're not on hard money for the summer.
That's pretty cool. I saw, like, I was doing my research and talking about you with the team. I was like, dude, this guy's super smart. I was laughing because you're like, you've got MIT, Harvard, and then just now you're telling me you're a professor at Stanford and you had done work with those other. I was like, did he just write like a list of logos that sounded awesome and then went around and collected them? Tell me about like your upbringing as a kid. Did you desire to go to these schools? What were you into?
What was I into? Well, I guess from an early age, I was kind of into locks and keys. So I guess there's that, which maybe is indicative of how I ended up getting into my career. So, but I would say through in high school, I was mostly into music, and I grew up in Boston, and well, when I was like I moved there when I was about 10 years old, and so there was a thriving sort of underground music scene in Boston, so I was really into that. I was like doing a zine with a friend to interview bands and stuff, and then I did radio when I got to college. But I always had a little bit of a sort of thing about authority, I guess you could say. And so one of the things that that kind of drives me crazy is when, in the name of security, like less smart people prevent like smarter people from like doing what they need to do, right? And so this could take the form of like you're just a software developer and you need like root privileges to do something, and like the policy says you can't because some system administrator like won't let you do that, right? But kind of you can one of my formative experiences after college. So I applied to a bunch of grad schools, and I actually got rejected everywhere I applied, except the University of Illinois at Urbana-Champaign, which lost my application. But anyway, I didn't have any options, and my undergrad advisor was like, "Hey, well, why don't you just stick around at Harvard? I'll just hire you as research staff for a year, and then you can apply again," which is a really good deal. So I got a job working for my advisor, Mike Smith was his name. And one of my jobs was to kind of, at the time, even PhD students didn't have root privileges on their workstations on their own desks. And things were different back then. Like this was before the days of SSH. So most remote logins involved sending passwords and clear text over the network and stuff. So you didn't want people snooping on the network. But still, it was very restrictive to people who wanted to do operating systems research. So one of the things that I did was sort of break this monopoly that the system administrators had on sort of administrative privileges. And I even did some things that were a little bit pushing the envelope. Like I wanted to have DNS control, and so that we could like add our own hosts and stuff. And we'd had some problems where like we wanted to make some changes to host names, and it required like it took some time for those to go through, and so at one point one of the updates didn't go through in time, and so as a result it went through much later when we didn't expect it, and somehow sendmail started failing on a faculty member's machine, and that faculty member ended up losing an entire day's worth of email because I guess you weren't saving copies of outgoing emails by default at the time, and so that person was extremely upset. And so I was like, damn it, like I want to get control of this. So I found, I kind of read the source code for the script. I found that there was this ambiguity between calling the is space, which is a function that returns true for spaces tabs, but also a couple of other characters like control K and control L, and actually parts of this script that were just searching for like spaces and character returns. So I somehow, by embedding like some control K characters in the script that they were processing to do the DNS, I was able to kind of force them to delegate our subdomain to us. And so I kind of did that on a Friday. And then on Monday, I told the IT, this kind of central university IT people, so guys, this is what happened. And after I'd requested several times to do this, and I was like, so this is what happened. And this is how it's working now. And if you change it, you risk like, losing faculty members more email or whatever. And at that point, they were just like, fine, we'll just take the path of least resistance. So when I left that job, they gave me a little plaque saying, creator of the eecs.harvard.edu domain, because I had sort of created that DNS subdomain through sort of somewhat illegitimate means.
I love it.
But anyway, that you can sort of trace that. That's why it's interested in. My thesis was on a network file system in which sort of anybody could unilaterally like add their own file server and be part of the namespace, and then you can trace that into my work in peer-to-peer systems. And that's obviously what appeals to me about blockchain. That if I want to set up a traditional financial services company, I need to get payment rails and banks and stuff. And these people have first-class access to the payment networks. And I'm kind of a second-class citizen, right? I'm programming to whatever APIs they deem, necessary to provide me, which might not be what I need. And so the idea that you can have a sort of egalitarian API where I don't care if you're a Ph.D. student at Stanford or, a giant company like IBM, if you're programming for blockchain, everybody has access to exactly the same APIs. And that sort of forces you to, it sort of makes it inevitable that anybody can innovate. So there's no longer this sort of gatekeeping function that if you have ideas, but you don't have access to the payment rails, you can't necessarily implement those ideas.
Yeah, but that's how you maintain control.
Sure.
Right? Like I want my fees. I want my money. Right? That's when I saw what you guys are doing, I was like, this is awesome. I wonder what type of legislation is going to come out, because I have a very small amount of experience, about 3 years in the financial services industry where I was building like large scale applications. And so I know enough to understand this concept of like, I want to send money to someone in another country. It will hop several times through like the wire will go through multiple systems. It's craziness. And everyone's kind of taking a little fee and a little chunk as the money's going. But if I could just send the money like directly to the person, right, that would make so much more sense, but it would cut out all of these existing networks and all of these fees that they're getting.
Yeah, I mean, look, I don't mind fees as long as it's not rent seeking, as long as I'm getting something in return, and in particular, as long as there's competition, so that if you're charging too much, someone else can come along and compete. I mean, I don't think blockchain is the right. I think it's a good infrastructure. I don't necessarily think it's the right sort of end user interface for 6 billion people who might want to send money at some point. But what I don't want to. So there's value in sort of owning the customer experience, being able to provide services like password reset when people lose their ATM card or their password. But what's bad is when you have sort of you no longer have the need to innovate because you can sort of like lock out because nobody else can the people who can innovate don't have access, and since you have access, you don't really need to innovate. And the innovation, of course, also includes better experience, lower prices, lower latency, things like that.
So what does Stellar do? How does Stellar help solve these problems?
So Stellar is specifically designed for around the idea of issued assets. So the idea is there's sort of in contrast to algorithmic stablecoins, things like MakerDAO, where there's some fancy algorithm that manages to keep this coin in line with the value of the dollar. What we do is we say, look, actually, as a society, we have invested a fair amount in sort of this whole regulatory infrastructure to make sure that our banks are solvent and, ideally don't rip off customers and things like that. So we should leverage that, and we should have our, banks and other regulated financial institutions issuing digital dollars and other digital currencies that then have all the advantages of blockchain, like you can send them around the world and in just seconds. And in particular, one thing that happens a lot is if you're going between sort of two currencies that are not like G7 currencies or whatever, if you want to get from Philippine pesos to Nigerian naira or something, right now you probably have to buy dollar, and so now you're taking like exchange rate risk on that dollar. If your money gets stuck in the middle and like doesn't make it to Nigeria and has to get converted back to pesos, you might not get the same exchange rate. Like there's all this like complicated stuff. And so what we want to do is allow people to issue all these various currencies and allow anyone to trade atomically currencies that were issued by different parties, like maybe a Nigerian bank and a Philippine bank, and also potentially trade through intermediary currencies without ever taking either exchange rate risk or even solvency risk on the intermediary currencies. We call that a path payment, where you go from currency A to B to C, and there's never a scenario in which you end up holding the bag on B. You either have A or you got all the way to C.
Interesting. And so this is something that's available to happen right now.
That's right. So basically, anyone can create an account on Stellar. I mean, so we do have a cryptocurrency. It's called the Stellar Lumen, and there's a minimum balance. So to create the account, you need, 1 lumen, so which is worth about 50 cents. And then to add extra kind of balances in other currencies, you have to add like half a lumen. So let's say for the price of $1, you can create a Stellar account. What you do is you generate a public key, and you have the private key. The public key names the account. You create this by depositing your 2 lumens, which are worth about $1, into this account. And then you can sort of add balances of various currencies that you want to hold. But also, as the owner of an account, you can issue your own currency. And the only catch is, of course, that the name of your account is part of the name of the currency that you've issued, right? So you can't just issue US dollars. You have to issue like US dollars that were issued by your particular account. So in my case, like you shouldn't trust a dollar that I issue because I'm not a bank. Who am I? How do you know I'm going to redeem my dollar? But there are organizations like say Circle and Paxos and so on who have issued dollars, and they have a way that you can redeem these dollars. And so as long as those organizations and their banks stay solvent, then you can basically trust that this digital dollar is equivalent to a real dollar.
Interesting. Okay, so where did that name Lumens come from?
Well, it's kind of funny. So we first initially, when we launched, we had this older code base that was a fork of this other blockchain, Ripple, but we wanted to kind of start over and not do backwards compatibility because we had the original Stellar didn't have my consensus algorithm in it. It was just kind of a way to get us out there. And so we decided that we should change the name when we switched over to the entirely new blockchain that we'd written from scratch. And I like biking. I commute by bicycle or bicycle and train, but sometimes just bicycle. And at night, this visibility is an issue. But nowadays you can get these really powerful bike lights that illuminate, they're like brighter than like a motorcycle headlamp, and these things will run for like an hour. Like one brand that I like is Light in Motion, for example. I wouldn't say their lights are that durable. I've had some batteries burn out, but the beam pattern and the brightness, like really phenomenal. So anyway, when I first started getting into these lights that just transformed my experience biking at night, I was so excited that I always just wanted the light with the most lumens. I even named my desktop machine at Stanford Lumen. And this was kind of before, and then they were talking about like, so should we change the name? And then someone else actually, I think it was Joyce, suggested the name Lumen, and I was like, yeah, I love lumens. We should totally do that.
I love it. That's
So a lot of
good.
people
That's
think my
good.
machine is called Lumen because I'm naming it after Stellar. It's actually the other way around.
That's beautiful. That's beautiful. I actually got to do an interview with one of the creators of Ripple. So that was some of the initial inspiration.
Yeah, so Jed McCaleb, who's my co-founder at Stellar, he was a co-founder of Ripple as well. So
Oh,
in
cool.
some sense, he basically had differences with his co-founder at Ripple that were sort of irreconcilable. And so Stellar is kind of his attempt to do it right. And so that's why he got in touch with me. One of the, there were several things that he, I think, regretted about Ripple, including sort of like the for-profit structure that left, ambiguity about, are you serving the network or are you serving shareholders? But one of the things he regretted was the consensus algorithm. And so that's why he got in touch with me. Obviously, that's where the Stellar consensus algorithm came from.
We have such a wide audience, like people that specialize in all sorts of different things. So can you like just give me, like, pretend I'm a 3-year-old and explain to me what a consensus algorithm is?
Sure. So consensus is this problem in distributed systems where you kind of have a bunch of agents who can communicate by sending messages to one another, and you give each of the agents an input, and the goal is for them all to create an output, and you want everybody to create the same output, and you want that output to actually be equal to one of the inputs that you provided. Because if you don't have that, then everyone could just always output 0, and that would be an easy consensus algorithm. And so typically, there's 3 properties that you would want of a consensus algorithm. One is agreement. You want to make sure everybody outputs the same value, or at least all the nodes that haven't failed. Second, validity. That's that the output value actually equals one of the input values, so it's not a trivial problem. And a third is fault tolerance, which is that you'd like to be able to survive the failure of an agent at any point in the execution of your system and still have the non-faulty nodes output a value. So sounds like something reasonable to want. However, it turns out that there's a seminal result in distributed systems due to Fisher, Lynch, and Patterson, which says that in a purely asynchronous system, meaning if you don't know how long the delay is on messages, it's actually impossible to achieve all 3 of safety, liveness, and fault tolerance. So liveness would be sort of termination, the fact that the thing will actually terminate and output a value, right? So this means if you want a protocol that it can survive failures, it's consensus in the sense that it will output a value that was an input value and everyone will output the same thing. And also it won't get stuck. It will, not stuck, but it will definitely complete and output a value. That's actually impossible unless you start making some assumptions like saying, well, if a node hasn't responded in an hour, then it's really dead. So this means that this seemingly simple problem of consensus is actually fairly complex, because you can't have it all. And so what people typically do is they design protocols that are safe and fault tolerant always, but are not guaranteed to terminate. So they lack liveness. But they will terminate kind of in practice, and they also can be guaranteed to terminate if you make other assumptions, like, for example, the delay of messages doesn't grow without bounds. So the typical setting for a consensus algorithm is to say you have say some number of nodes, like n nodes, and you have some quorum size that might be n over 2 plus 1 or something, like some majority of the nodes. And so then, as long as there's a quorum that's alive, they will agree on they will be able to achieve consensus, basically, subject to certain timing requirements. So that's kind of a typical consensus setting. That what I said, where you have n over 2 plus 1, a majority of nodes, that only works if you assume that nodes that fail do so by just crashing and dying, right? If you assume that the nodes that are faulty start acting arbitrarily, like maybe they're taken over by an attacker whose express goal is to try to mess up consensus, then it turns out that you need something like, you basically, out of 3 f plus 1 nodes for some integer f, you can survive only f failures. So basically, you can survive less than a third of the nodes failing.
You must be talking to some smart 3-year-olds, dude.
Sorry, yeah, I guess this is.
I'm learning a lot. I'm following it, but I am not this smart.
Well, maybe I should back off and say, like, so why do we care about consensus?
There we go.
And the answer is that if you want a replicated system, you actually need all the different replicas to agree on what has actually happened to the system so that they end up with the same state. And so the typical way that you build a distributed system, and in particular, most blockchains work this way, is that the blockchain itself is what's known as a deterministic replicated state machine. So everybody agrees on the initial state of the machine. Everybody agrees on the entire history of operations that have happened to this. All the operations are deterministic. Therefore, everybody ends up in the same end state.
Right. So the consensus is you're just trying to get everybody to agree on something.
Exactly.
All right. Cool.
And so Bitcoin does this, for example. So Bitcoin has a solution which is actually not safe. So it is guaranteed to terminate, it is guaranteed liveness, and it is guaranteed fault tolerance, but it does not have guaranteed safety. But what they do is they make it so safe in practice because they, in order to compute the Bitcoin blockchain, you have to expend a huge amount of computation, and this computation takes into account the entire history of all transactions. So as you add more and more blocks and more transactions to Bitcoin, the amount of work that went into this blockchain grows greater and greater. And if you want to rewrite all of history in Bitcoin, you have to redo all the work that these miners have done. And the thing is, even though the work itself is very hard to do, it's very easy to verify that someone has done the work. So you couldn't just create a fake Bitcoin and say, well, I've just done, all this hashing work, because people would just check your blockchain and say, oh no, you haven't actually done that work. Either the hashes don't match, or there aren't enough zeros, kind of the hardness factor wasn't there when you did the work.
Is Stellar like a currency that you can mine? Can you explain to me like mineable versus non-mineable?
Yes. So this is kind of, remember how I said at the beginning that the two amazing things that Bitcoin brought us were this consensus essentially across mutually distrustful parties who've never heard of one another, and in an open membership setting. And second of all, the ability to create a new currency out of thin air, distributed in such a way that there's a limited supply and people believe it has value. So that's where the mining comes in. The mining is the work done to compute over the Bitcoin blockchain and extend it by one additional block so that the history grows. And basically, what mining is it's the reward. It's the process of obtaining new cryptocurrency as a reward for making it harder for people to rewrite the history. So basically, as a reward for increasing the security of Bitcoin, you get some new Bitcoin, like whatever it is, six and a quarter Bitcoin or something Bitcoin, right? So. So this is really cool, and there's open membership. It has a reasonably high degree of security, although there have been sort of forks or times when the history has been rewritten by some number of blocks. But by and large, it's worked pretty well. It has a pretty high ecological impact because it requires electricity to run all these machines to solve these mining problems, and it adds latency. In the case of Bitcoin, you probably want to, if you really care, because it's a high value transaction, you may want to wait for like 5 block confirmations, and so that could take the better part of an hour, for example, to do. And so with Stellar, we went in a different direction. We said, look, we don't want to do this mining because we want to concentrate primarily our use case is people issuing assets on this network. And so you don't want to be in a situation where maybe you're super successful and your cryptocurrency has a market cap in the tens or even hundreds of billions of dollars, right? And then some central bank comes on and says, great, we want to issue, $1 trillion worth of currency on this thing. Well, now, if the security of these transactions that are happening depends on the mining rewards, those mining rewards depend on the value of the cryptocurrency. So you now have this cryptocurrency, which is worth less than the digital fiat currency that's been issued on the network. And so you're using the less valuable thing to secure the more valuable thing, or the value of the less valuable thing to secure the more valuable thing. And that equation doesn't work. So it'll work fine up until people start using the network for most of the value starts being not the cryptocurrency, but the other currencies. And so kind of what's different in Stellar's setting is that, well, if we're primarily designing for these people who are going to be issuing currencies, well, then you're kind of trusting the people who are issuing the currency, the digital currency, to be solvent and to be, either honest or in a country where they can be held legally accountable if they do something bad. And so if we're trusting them for solvency and being honest and to redeem these digital assets, why don't we also trust them for consensus, right? And so that way you could say, hey, you issue on Stellar, you tell people that, hey, this thing is worth $1 because you can redeem it with me and I'll give you $1. But by the way, here's my server, and this is a server that I listen to when I'm redeeming these digital dollars you're sending back to me. So if you care about my digital dollar, then you should listen to my server and make sure that you agree with it before you think anything has happened. So the central idea behind my consensus algorithm, which is called SCP, the Stellar Consensus Protocol, is that you have all these nodes in the system, and each node says, hey, these are the other people that I want to agree with. So basically, I won't believe that anything happens unless you agree also that it has happened, right? And this ensures that you and our views of the database will never get out of sync. And so the assumption kind of underlying Stellar is what I call the internet hypothesis. It says that basically, if you look at kind of the organizations that everybody wants to stay in sync with, that each organization wants to stay in sync with, that transitively, any two participants that you care about will share some transitive common dependence, right? And this, I call it the internet hypothesis because this is true of the internet, right? There's no formal definition that the internet is the particular IPv4, IPv6 network that contains, Google and Amazon and Apple and whatever. But if I showed you another network that had the same network protocol but didn't have any of the existing websites, there's no way you'd believe that that's the internet, right? So we all kind of have this notion that we know what the internet is, even though it's not strictly defined. And the internet has this sort of transitive connectivity property where sort of if you're in China, you can't access Google, right? But you can certainly access Stanford, and Stanford can access Google. So kind of transitively, it's still one internet. And if you created a network that was entirely disjoint from the existing internet, no one would think that was the internet. So that's the same way in which we want to tap these relationships, these dependencies between people, to have the whole world agree on what the state of the Stellar network is, without sort of having to prescribe it in a centralized way.
Yeah, as you were explaining it, it sounded like decentralized consensus. I don't know if that's correct.
Yeah, that's right, basically what it is. I mean, so you could argue that it's on a spectrum, right? That it's maybe not quite as decentralized as Bitcoin, but it is open membership. And more importantly, there's no central party that decides who has what importance. It may turn out if the Federal Reserve came and issued a digital dollar on Stellar, you can bet that almost everybody would want to be in sync with whatever the Federal Reserve, we call it a validator. That's like their copy of the ledger state. But not everybody would have to, and certainly people could asked to be in sync with other organizations like, the European Central Bank. And so if then the Federal Reserve and the European Central Bank started disagreeing, then I would just stop and I would not accept anything. And I would say, we got, hold on, I don't believe anything anymore, because like these two people I think are so important, like seem to be out of sync.
Oh, interesting. So that can be configured. Oh, that's fascinating. You guys are like blowing my mind. This is actually really, really interesting. I found you because I saw on the news, I think you were doing some work with Ukraine, like the Ukrainian government chose you to help figure out their strategy for digital currency. And I started reading about it and looking into Stellar. And I was like, this looks really, really, really interesting. And I was thinking to myself, okay, well, these Ukrainians, if they're picking them and they're a country and they need help with their strategy, there are a lot of countries out there. And so other countries are going to start looking like, who can I use for this? And then they're going to get all Ukrainians friends. And then eventually this is just going to grow and grow. And this company, Stellar, is going to get good at helping countries deploy these digital currencies. So I want to experiment and own some. So I bought some Lumens, I think is what we're calling them, right? They're Stellar Lumens. That's what I bought on Coinbase. It's like, I'm going to buy some of these Lumens uh, because I want to keep up with what's going on with Stellar. I think it's just cool when things that are out there that I don't understand, but they're interesting enough for me to keep checking in on them. I like those types of things.
Right. Yeah, I mean, I think that ultimately, I think that Stellar can be the glue that that allows all these different digital currencies to be able to interoperate. I mean, one of the things that we've often said is that we want Stellar to be like email for money, basically. So basically, a lot of people who send email, they use Gmail, right? And that's fine. So Google might own some like large fraction of the email, in some countries. But the point is that email itself is an open protocol. And so if you want to use Yahoo Mail or you want to use, Hotmail or whatever, like you can use that as well. And they can sort of interoperate with all these other email providers. And also, if you're crazy like me, I wrote my own mail server from scratch, right? And so like I had the ability to innovate and interoperate with all these other systems because it's on a level playing field. And I don't know, my email system might not be right for most people, but it's right for me, and it's open source, and so other people are welcome to use it.
What's it called?
And it's called Mail Avenger, mailavenger.org. So, nice. And so this is in contrast to something like Facebook Messenger, right? Where Facebook Messenger is whatever Facebook says it is. You can use Facebook software if you want to interoperate with that. They own all the messages, and it's kind of like you can't innovate if you have like some cool idea, even if they did let you innovate. If you built a company around Facebook Messenger and you were successful, Facebook could just pull the rug out from under you. They could say, that's a nice profit margin you got there. How about you give us 50% of your profits and we won't like shut you down, right? And like you'd be at their mercy, basically, right? And so we're specifically designing Stellar such that like you can't be at anybody's mercy. Like if there was some issuer that issued, super valuable, like let's say someone put like $1 trillion digital dollars on this thing, right? Then everybody would want to be in sync with that person's validator, because that would be like such an important asset trading on the Stellar network. But if that person acted like too erratically and started like not approving transactions or trying to block things, the rest of the world could say like, you know what, we're going to remove you. We're no longer going to listen to you. We're going to come to consensus on our own, because like you're basically hindering the operation of the network. So you can still follow us, but we're not going to listen. We're not going to wait for you for agreement. And ultimately, I think that's really the only thing, the only model that works, where like different people have different amounts of clout, but the clout is determined in a kind of decentralized way. And that's how the internet works, which was a huge inspiration for Stellar's consensus algorithm, right? There's no kind of internet authority that designates tier one ISPs, right? So there are these tier one ISPs that are so big that they don't buy transit from anyone, right? But what's a tier one ISP is kind of in the eye of the beholder, and it actually changes over time. And there's very interesting market dynamics. And sometimes people play chicken, right? Like there was a famous case where level 3 was this ISP that went to this other ISP called Cogen. Cogen is a famously kind of low price ISP, so typically you'd use them wherever you can, and other people for where Cogent doesn't work too well. But level 3 went to Cogent, and they were peered, and they said, "Hey, Cogent, you're not really a tier one ISP. How about you pay us for transit, or else we'll depeer you?" And Cogent was like, "Okay, we dare you." And so then there was a period of time when suddenly people couldn't communicate because Cogent and level 3 had level 3 had depeered them, and this was a big deal. And then finally, they came up with some settlement, which of course was confidential, and they reconnected. My guess is they're still peering, but Cogent had to carry more of the long haul traffic. But the point is, there was so much pressure from customers on both sides, particularly level 3 side, since they weren't like a budget ISP. But then this kind of turned around and bit the precedent might have bit level 3 in the future, because then what happened was level 3, I think, had a contract with Netflix, and Cogen, which is typically not viewed as a tier one ISP because they just have the end users, right? So they just have the eyeballs. Comcast went up to level 3 and said, "So level 3, it's a pretty nice contract you just inked with Netscape. It'd be a shame if suddenly everybody started having really crappy experiences with Netflix. How about you pay us for transit to reach our customers," right? And level 3 actually had to cave to that. So there's this sort of game of clout that goes on. And some people do have a lot more clout in the system than others, and maybe they abuse the clout, but it has actually worked to create this global network called the internet that is not centrally managed and that works pretty well. So it's kind of remarkable that this works. And that's why I want to do the same thing for consensus, so that you could basically not only communicate with anybody in the world, but perform secure atomic transactions with anybody in the world, trading, arbitrary assets that kind of any two parties in the world have issued, just the way sort of anyone can send email to anyone today over the internet.
That's interesting. Has anyone used the phrase Internet of Payments yet?
I mean, I think a phrase that we've used at Stellar is email for payments. Yeah.
Yeah, because I understand how email servers work. So I do know some stuff. So my background's software engineering for 17 years, and I primarily focused on B2B, large scale applications. And so when you started explaining it about email servers, right? Because it goes email server to email server, there's lookups and everything, but I don't have a great verbal explanation for it, but there's an excellent mental picture in my mind about how email works and exchanges and that format. But when you said that format applied to payments, it just instantly clicked. It's I get what you guys are doing now. I actually have coming up, and I think next month, Sir Tim Berners-Lee, one of the creators of the internet. Do you have any good questions?
Of the web.
Yeah.
So the internet, dates back to many, many decades, right?
So yeah, help me understand the difference.
Well, I mean, the web is just one particular application of the internet, right? It's like HTTP and HTTPS, and
that's what he worked on.
That's right. He invented.
Oh, okay. See, I didn't know
basically, that. and possibly HTML as well. So the idea of this hypertext system where anyone could link to anyone. And I mean, that was a big inspiration to me in my thesis work for my dissertation at MIT, right? Where I said on the web, the value of the web is that anyone can set up a web server and anyone else can link to that web server. And at the time, there were these distributed file systems like AFS, which still exists. But in AFS, you had to kind of list all the servers that you want to talk to in this file, it's called like, I don't know, user vice self-serve dv or something like that. And so basically you can only talk to the servers that your system administrator had put in that file. And I was like, that sucks. What if I want to set up my own server and like access it from some of these machines? And so my dissertation was about this global file system where anybody could add a server, and then you could sort of connect to any server from any other server, link to any server from any other server, much like the web.
So explain to me. So I'm only 33, right? So I grew up and the internet, I think it was like super, or the web to me, the browsers were like super, super basic, right? I think at some point or at the beginning, there weren't even really the browsers, but I do remember because my dad was an engineer, so he would give me little projects and things like that. But help me understand the internet without HTTP.
Well, I mean, it's so that you had email, you had things like FTP, you had things like Telnet and RSH, RLogin, which were precursors to SSH. I mean, network time protocol. I mean, there's all kinds of DNS for looking up host names. Like Stanford.edu. So all of those things predate the web, right? And I mean,
Interesting.
I remember when I think I was in grad school, the first time I saw a URL in a Subway advertisement, I was like, wow, this is kind of a big deal. Like this thing is kind of like really mainstream. I was in Boston at the time.
Okay, so I'm gonna be like, I just want to know. I'm just curious, like between us. Okay, so like when you type into like in a web browser, I guess, all right, so I know what SSH is, right? Because that's how I get into my server. So when I'm just because I do the SSH and it's got the colon slash, so that's not what would you call all of them? Like, how do you refer to SSH and HTTP?
Well, they're all protocols.
So they're
So there's
protocols.
this sort of layering model, where the idea is you have a like a physical layer and a data link layer. So this might be like sort of Ethernet. So like the bottom physical layer would be like a twisted pair or fiber or like a radio or something, and then you've got the data link layer, which would be like Ethernet frames, like the Ethernet packet format, and then you have the network layer, which is like IP, and then on top of that you have the transport layer, which would be like TCP or UDP, and then on top of that, essentially the upper three layers often get that don't always necessarily make sense, but on top of that, you have some kind of application layer, and so in the case of TCP, UDP, and UDP running on top of IP, there's tons of these protocols. And if you look at the file etc services on any Unix or Linux machine, you'll see a bunch of protocols that are there, and everything from network file systems to email to remote login to network time protocol.
Interesting. If I wanted to Google for like a graphic of these layers in the stack that you just described, because it's
If
helping
you
me.
just look up OSI 7-layer model,
7-layer model. Awesome. Thank you. Because
but to be honest, the top 3 layers are like I don't know how much they correspond to reality. Typically there's just like some application sitting on top of the transport layer.
are you following Tim's work with his like new internet concept?
Not super closely, but what I've seen, I like a lot. I mean, again, should at this point probably be clear from context in terms of the things that I care about, right? Like I don't like the idea that of being locked into some service. Like all my photos are in. If they're all in Instagram, then I can only access them through like Instagram's API. Whereas if you could sort of disaggregate that stuff and like the storage is separate from like the service on top of that, then the minute I get sick of Instagram, I could like go someplace else and use them to serve my photos.
Yeah, I like that independence, right? Or how one of those like Apple will ban an app, from their app store. It's like that kind of sucks. Like, where's the app store that doesn't get banned? Right? I like to police ourselves. And I know right when you started talking at the beginning and you said that you have a problem with authority, you became my best friend. I was like, me too. I don't like people telling, I don't like being told what to do, because often the people that are making those rules are less intelligent. And it's
Yeah.
like, hmm,
I mean, I would argue, given the status quo, I think you actually need people to police the app store. But part of the reason is that like most people don't have root on their own phones, right? So this drives me crazy. So of course I would never carry around a phone that I can't root. But because I've rooted my phone, I lose access to a bunch of services. Like I can't use Google Pay, right? Because Google Pay doesn't work. Even if you haven't rooted your phone, just unlocking the bootloader on your phone means you're not allowed to use Google Pay because there's hardware attestation of whether your bootloader is locked or not. And so, yeah, you've basically got a situation where there's, maybe 1,000 engineers at Google who like basically decide what the ground rules are for everybody else. And then how many Android developers are there? Probably like, tens, hundreds of thousands. They're just working these little boxes that like Google is putting them in. And that drives me crazy, right? I want everybody to be able to innovate on an even playing field, everybody to have access to the same APIs. And again, that's kind of what drove me to work in security, because yeah, you have to worry about security in that case. But in a lot of situations, I feel like you can actually improve security and improve freedom, because the less you need to trust people, the higher your security, because your perimeter of trust is smaller. Your so-called, we often call it the trusted computing base, right? So smaller attack surface, smaller trusted code base, and more freedom, because more of your code is untrusted, therefore more of your code doesn't need access to special APIs to do what it needs to do.
I always look at things, or when I give talks out in public, which used to happen, right? I would always say, what are the things I want people to walk away with, right? Because you have the forgetting curve, the rate at which you forget information. And it's like, what do I want them to walk away with? So I was thinking, if anyone's going to walk away with like 2 or 3 thoughts about Stellar, what would those be?
Well, about Stellar, I guess that it's possible. We have an existence proof that it's possible to have an open payment network, which is entirely self-serve. So if you have an idea you want to implement, you can unilaterally implement that on top of Stellar, basically.
So if I wanted to make like a podcast token, right? And then it would somehow be currency, maybe like past guests, like you would come on my show and I'd be like, all right, you were great. I'm going to give you some of this currency, and we could somehow set up a network, and it could, between other podcast hosts. I haven't really thought about this, but you can just do that, right?
Yeah. And you can create a market between assets. So, if you want to know whose podcast is worth more, well, I don't know if that necessarily makes sense, but I've often thought that, do you know the website Stack Overflow, or the Stack Exchange, right? It's a network of websites, and you get reputation on one website, but it doesn't really help you on another website. And it's that's too bad, because it would be cool if I could, earn a bunch of credit answering questions about Linux, and then like trade that in to add bonuses for like legal advice or something on like a different Stack Exchange. So, certainly, I don't know whether this makes sense from a business point of view, but from a technical point of view, you could totally tokenize your reputation and create a market for reputation. And then, websites could actually, we actually have some kind of measure of like how much reputation is worth on different websites. Now, that might or might not work, right? So economically, it could turn out that there's well-resourced attackers who, like, for them, it's worth $1 million to like buy up a whole bunch of credit and then like spread misinformation on some platform or something. So I don't know, but it's at least technically possible to build that kind of exchange.
Interesting. Okay. Yeah, what brought it up is like, I was just curious when I heard that you can create your own tokens. I was like, what's the fun example to talk about that would work? Like, is there a podcast token? And so I Googled, and there's no podcast token. I wonder if there's a way for us to like exchange like value somehow with a token. and without it being cash. Like maybe like I have some sort of credit and they have credit and we can somehow exchange them, introduction to other guests, things like that. But I don't really know.
I
Just
mean,
in the back of my
basically,
mind.
I think that the way I look at it, and I don't know exactly how it applies to podcasts, but there are a lot of situations where where there's a lack of sort of transparent, well-functioning markets, and that's causing inefficiencies, right? Or it's causing unfairness, right? Like people might not be getting fairly compensated for their labor or their goods because there's like not a transparent market, and so ultimately, I'm a big fan of, regulated but very transparent and liquid non-monopoly markets as a way to kind of increase opportunity and increase fairness. And so anything where you think like, well, if there were a market for this, if there were like a liquid sort of good market for something, then Stellar is like a great way to bootstrap that market, because you can create the asset and you can instantly list it for sale in exchange for any other asset, like say USDC, which is worth $1, or Lumens, which is our native cryptocurrency.
Yeah, my last question just for us, right, about lumens. So like I own, I don't know, like 2,500 lumens or something, right? Um, what can I like do with them? Like what do I do with them? Like are lumens like your proof of concept for what you're allowing other banks to do?
So lumens there's lumens are different. There's a difference with lumens, which is that they're the one currency that doesn't have a counterparty. So it's kind of a neutral currency that has value as long as the whole internet is, as long as the whole network stays together, right? These lumens will have value. And there's a couple of reasons why it's useful to have a neutral currency. One is that it's just an anti-spam feature, right? We don't want someone creating like, a billion accounts on the network just to spam us. And so each account has like a minimum balance in terms of lumens, which I said is a lumen. Now you can get that back. You can merge your account with another account and get back the lumen. So it's just a deposit. But that limits, creating too much ledger state if you're not willing to pay for it. And the second thing is there's transaction fees, which are like pretty small, but if the network ever becomes congested, then essentially it turns into an auction where like the more you bid in lumens, the more likely you are to get your transaction into the block.
Oh, so it's a way to bid on the network.
That's right. Like if there's limited capacity on the network. Now there's a second use, which is that it's maybe useful for market makers, in terms of if you want to, like I said, we have these like path payments where you can go from like A to B to C, or A, B, C, D even. But different assets might have sort of different regulatory requirements attached to them. Like maybe in order to like hold dollars, you have to get approval from whoever issued them, because they're responding to whatever regulatory pressures. And so there might be a lot of people in the world who they just don't want to touch dollars. And today, sort of by necessity, just a lot of stuff ends up going through dollars, even though the two ends of a transaction don't care about dollars. And so Lumens provides an alternative. And we're not forcing this on people, but certainly if everybody who created a new asset decided to make a market for that asset in terms of the lumen, then you'd sort of be able to get between any two assets in a sort of a two-hop path payment. Or they could choose to use dollars for that as well, right? But it's another option that we have on the table.
Interesting. All right, cool.
And every account can hold lumens, so there is a slight benefit. You have to consent to hold other assets, because we don't want people spamming you with assets that you don't care about. But it's convenient that everyone can hold lumens. So I guess that's the value of the lumen.
Nice. How will the price of the lumen go up?
I don't. So first of all, we don't. Lumens are a utility token, right? So we don't in any way promote it as something like that's intended to increase in value. Right now, to be honest, I just think there's a lot of volatility in the blockchain space, and a lot of it is due to speculation and exogenous events. Like at some point, this NFT craze is probably going to crash, and that's probably going to hurt all the other cryptos, including things that aren't particularly doing NFTs like us. So I just think it a lot of it is not a lot of it is speculation and not necessarily grounded in the economics of these tokens right now, unfortunately. So
in context specific, like what would, all right, so there's two parts. There's like the people and the hype that's making things go up or down. Then the context of your example of how you can use Lumens, and they're used to help bid on fees if the network's congested. And is there anything built into like that concept? Like would it be like, let's take hype out of the equation. Okay. If the networks get bigger, will the lumens be worth more, or is there like infinite lumens, or like how does this work?
no, there's a fixed number. There's essentially 50 billion of them, or maybe less, because now the transaction fees get burned. So well, there were 100 billion, but then we decided that we just had too many of them belong to the foundation, the Stellar Development Foundation, so we burned about half of them to leave 50 billion.
Yeah, that was the same XRP problem. I mean,
what?
right? That's like,
Yeah.
that was like a similar to the XRP problem.
And well, but one of the things that we tried, we wanted to give them away to everyone. So we were doing like Facebook giveaways. So before airdrops were like such a trite thing, we were like, one of the first people to try like really large scale airdrops.
Oh, cool.
And honestly, what happened was it worked at first. And then it sort of seemed to get like spammier and spammier, as we went along. So it's kind of one way to view cutting supply in half is it's a way to double down on the early distribution that went well, without sort of continuing now that people, now that airdrops seem like a scammy thing, and that like people know how to game them better anyway. So
interesting.
But our one of the reasons that we're a nonprofit is our goal is to promote adoption of the network, and in general, like our mission at the Stellar Development Foundation is to create equitable access to the global financial infrastructure, right? And right now we think that the best way to do that is through the Stellar network, and probably we're going to continue to support Stellar and do that, but we're definitely not, our goal is not to increase the price of Lumen or whatever. It is to create this equitable access to financial markets.
And the reason why I buy as a nerd is just because it's cool. Like, I'm like, all right, I like to support stuff with my dollars, right? If I think something's cool, I'll like buy a mug, all right, like of a brand or something. Or if I think something's cool, I'll buy a hat. And so in this case, I'm like, oh, what they're doing is actually really cool. I read your whole thing on your Stellar site, and I was like, this is pretty neat. And I was like, I want to buy some of this because I want to support that.
And if you do issue a podcast token, then you already have the Lumens. You need to set up your initial account and set up a market for it. And
I love it. I love what you're doing because I mean, I think I already said it, but like the way it looks to me is all these banks have their own APIs and they're trying to like connect with each other. And you're like, oh, let's create this standard or this API over here that anyone can plug into. And that just sounds really, really smart, because what it does is it lets everybody come online in their own timing. Versus if I were like a commercial entity and I was trying to push an API and get adoption within a market, I would have to go around and set everybody up and teach my methodology and like put cost, and then there would be a cost structure behind that and then the deployment of it. But if you say, hey, we're like this open solution, here's the information, you can just go ahead and do it on your own timing, then people can come and mosey on in as they see fit or as the needs arise to them. And honestly, I think that's like a beautiful thing. So that's why
I mean, there's Metcalfe's law, right? The value of the network increases quadratically with the number of participants, right? This is one of the real value propositions of the Stellar network, that you integrate once, and maybe you initially integrate with Stellar because there's like one particular organization that you want to partner with to say like do remittances to one particular market. But now if you suddenly want to access another market through Stellar and there's like a payout partner there who's already integrated with Stellar, it's trivial. You're already integrated with Stellar, right? So it make you kind of integrate once, and then you can interoperate with everyone. And right now, this is a thing that like totally doesn't work with remittances, where it's just like so much labor goes into like setting up the payment rails to each individual market, that it's crazy, right? And that's why sort of people who are lower down on the kind of size of the economy, right, they just aren't going to get the same priority, and therefore they're just not going to get the same level of service, and the same cost structure, right? That's why, like, if I want to send money to Europe, I pay like well under 1%, right? But like average remittances are like 7% fees, say.
That's smart. How much coverage do you guys have now? Like, can I look up that on the website, or how do I find that out? Like, how many currencies you
Yeah, I
support?
think we probably have links to various people. So we ourselves we're just maintaining the network, right? So think of us like the ITF, we're like specifying the email protocol. We even put out a reference implementation, which is the one that everybody is using.
Where's my
But
Google?
what?
Where's my Google? Like,
Exactly,
where's
right. Your
the
Gmail,
yeah,
or like
yeah.
who's your Gmail on there? And so, I would say, it's like Cowrie in Nigeria, and if you look at, we did actually put we made this product called Vibrant, that is an app for people in Argentina and other places to be able to, I think we've at least launched in Argentina, possibly other places, to save US dollars. So this is something there's a huge market for, is the ability to save US dollars in some way other than sticking actual bills under your mattress. And if you're not a US citizen, if you're like an Argentine citizen, you can't just open a US dollar denominated bank account. So this app is meeting a demand that's currently unmet.